Here's another theorem. Here we have a kite-looking shape. Now the theorem goes, the angle at the center is twice the angle at the circumference. And this is the case with this figure. Now the angle at the center would be COE, with O twice the size or 2 times the size of angle D on the circumference. Now if you spot the shape and angle C hasn't touched the circumference, there is no theorem. If angle D hasn't touched the circumference, there is no theorem. If angle E hasn't touched the circumference, still there is no theorem. If angle O is not the center, there is no theorem. So now you know that if angle O is 2x, then D will be x. Now with this theorem, they could fix angle C and angle E and only move point D in a way that it will make this figure look strange, as I'm drawing with dotted lines. The theorem will still apply anyway. Angle at the center is 2 times the angle at the circumference. Keep aware of it, especially if you have a diameter and a strange shape like this. Remember this theorem. You see what it looks like here? Far different to our kite. Still the same shape though, but only now point D has been moved, which is why it looks strange. Line CD is a diameter, so when you're given that, consider the theorem when you see such strange shapes. Now if angle O is 30 degrees, we can conclude that angle D is 15 degrees. Reason being, angle at the center is 2 times the angle at the circumference. Now let's assume they move point D with C and E fixed or still in the same position. If they move it further down, we'll get this dotted line, shape, which looks like a zigzag, and then apply the theorem. Angle at the center is 2 times the angle at the circumference. So over here we're given angle D, which is 10 degrees, to figure out our center, which is the angle COE. And this angle COE is 20 degrees. Reason being, angle at the center is 2 times the angle at the circumference. So we multiply the angle at the circumference by 2 as the theorem goes, and the center angle is obviously bigger. And our last case in this theorem is where D has been shifted to the bottom in such a way that it interferes with the center angle, which was COE, the angle, but O's exterior angle. What I did not mention is the reflex angle, or angles around the point. Now when you add angles around the point, they total 360 degrees. So since we have 160 degrees on angle O's interior angle, this 160 degrees is still not twice the size of angle D. But the reflex angle O, the exterior angle that is 200 degrees, which we figure out this way. We take 360 degrees and minus it by 160 degrees. So the reflex angle O is 200 degrees, and the reason being angles around the point from that theorem. Now this 200 degrees is the angle that's 2 times the size of angle D. So to get to angle D, we take this reflex angle O, which is 200 degrees, and then divide by 2. And then we get angle D, which is 100 degrees, and the reason being angle at the center is 2 times the angle at the circumference. And let's also not forget the reason we got the angle O. It's the theorem, angles around the point.